Hello again. So today we're going to be talking about how ionic solids, how ionic salts interact with water, and dissolution reactions, as well as forming aqueous solutions. Okay, so just to recap again, so ionic compounds, just like sodium chloride, these are a metal and a nonmetal that are being held together through these ion bonds. And there's nothing really necessarily holding them together except for the fact that in order to gain octet stability, they had to gain or lose electrons, which generated charge, and this charge opposite charge likes to attract, and as such, they tend to get kind of stuck to one another. And of course, these spheres can pack in three-dimensional lattices, and this is ultimately how we get our three-dimensional salt crystals that we can see in lots of different forms for minerals in the earth. So the question might be, if you take these salt crystals, and it doesn't necessarily have to be sodium chloride, it can just really be most ions, or most ionically bound salts, and you put them in a solvent, and especially water is a good solvent for hydrating ions. And so what happens? Well, I mean, we know in the physical world that seemingly the salt crystals disappear. So what is happening on a molecular level? Well, on a molecular level, we still have the salt crystal, but it's kind of almost like being attacked by the water molecules. And what's happening here is that the water molecules which are represented right here, they can both stabilize the positively charged ions, in this case maybe like sodium, as well as the negatively charged ions, like the chloride. So they can stabilize them both. And so if you get enough water molecules, they ultimately can surround each ion, and they can kind of pluck it off. And they can kind of disperse it throughout the water system. And so instead of having this kind of salt crystal, you now actually have individual ions that are surrounded by water molecules, and they're kind of floating kind of evenly in a homogeneous solution throughout the water. And so you can kind of see that here. You start off with maybe a pile of salt in the bottom of your water here, and slowly but surely the water molecules begin to associate on the surface here of the salt crystal, and they begin to surround and remove individual ions one by one from the salt crystal. The pile gets smaller until eventually you have a pretty much evenly dispersed solution of ions, and the ions are surrounded completely by water molecules. And when you have these solutions of compounds dissolved in water like this, we call these aqueous solutions. And even though we're not necessarily talking about something in which a chemical transformation has occurred, we do call these reactions. We call these dissolution reactions. And so these are reactions in which a solid is dissolved in a particular solvent. In this case, it's water. So what happens if you run out of water molecules? Obviously, let's pretend on a molecular scale you need 10 water molecules for every ion to fully solvate it, to make it so that it can freely move around in the water. Well, what happens if you just simply have too much salt? Well, that's called a saturated solution. So those are pretty easy to make. You can keep adding salt to a solution of water, and eventually, no matter how hard you try, you're gonna have some layer of salt on the bottom, and this is just basically sodium chloride. And what's happening here is that the attractive forces of the sodium and the chloride ions, so you have these positives and the negatives, and they're sitting on the bottom here, and these are still strong attractive forces, and there's not enough free water molecules to allow them to kind of coat these ions and to liberate them from the ionic solution. And we don't just see this in the lab, of course. There are places like the Dead Sea, and this is a picture right here, and you can see this particular sea is so salty that you actually get this kind of super saturated kind of water, where you're actually seeing water kind of precipitate out of the sea on the surface, and there's actually even these large pillars of salt underneath as well. Okay, so we were talking about making ions, and we're talking about making ionic bonds, and we're talking about making salts. And so now we're talking about breaking them apart. And so it's not clear, why is this significant? Why is this important? Why is it important to be able to make ions fully distributed in water, to make these aqueous solutions? And the important reason is because of electrolytes. So when ions are stabilized by water, that solution can conduct electricity. And so the reason for this is because electrons now can kind of, you want to imagine they can hop from ion to ion. And there's a lot of great examples of this. So we have maybe like a cathode and an anode. So these things, one is transmitting electrons and one is receiving them, and you have to complete the circuit to turn on the light bulb. And in just pure water can't conduct electricity at all. So in fact, if you were to get struck by lightning in a pool of pure water without any ions in it, you'd be totally fine, because quite simply water is a terrible conductor. However, if you dissolve salts, it doesn't have to be sodium chloride, it can be really any salts. If you dissolve salts in it, then it conducts electricity pretty freely. The electrons can hop from ion to ion, and you close the circuit. And there's lots of examples where simply adding salt to a solution allows the current to flow. There's even some great ones. This is a glowing pickle experiment. Pickles are really, really high in sodium chloride because you make them cucumbers. Basically, you dip cucumber in a brine solution, in a sodium chloride solution, and that's what turns it into a pickle. And so pickles conduct electricity quite well. And you can put an electrode into the pickle, and you cause it to kind of light up as the electricity passes through it. So we call solutions with ions in them electrolytes, and we call them this because they transmit electrons. And electrolytes are quite important to us as in any other animal as well. They do many things. They actually help kind of keep fluid balance between the cells in our bodies. But we actually need to transmit electricity in our central nervous system whenever we synapse fires or neuron fires. That's a form of chemical energy that we're transmitting, and so we actually need quite a bit of electrolytes in our body. And you can see here in this infographic the electrolytes that they're talking about. Once again, sodium chloride, potassium, magnesium, calcium. And so they're really talking about solutions that have sodium, chloride, potassium, magnesium, and calcium. And they're talking about these foods that are electrolyte rich. And these are foods that have high sodium chloride, potassium, magnesium, or calcium. Now the interesting thing perhaps is this bottle in the middle. So this is representing, I think, Gatorade, and Gatorade, and there's actually quite a few sports drinks now, but if you want to kind of take the essence of what Gatorade or any sports drink is, it is basically liquid sweat. And so one of the problems with doing athletics, being an athlete, is that you are sweating as you work out, and so you actually sweat out salt, and so you ultimately create a salt imbalance in your body, because you're not only losing water, but you're losing these important ions, these important electrolytes. And if you keep exercising too much, even if you just keep taking in water, you actually can get electrolyte imbalances in your body, which can be quite dangerous actually if you overdo it. And people figured this out quite a bit ago, and in fact, the Florida Gators were one of the first teams to implement this, and they created Gatorade as a trademark for their team name. And basically, what they did was they figured out what's in sweat, and they decided that they would just simply give their teammates liquid sweat so that they would rehydrate with the necessary ions that they need. And of course, sweat is terrible to drink, and so they also added a whole bunch of sugar to it as well, and that made it more palatable. And so that is really what you are drinking when you are drinking sports drinks. You are drinking forms of liquid sweat that help you rehydrate and help you get your electrolytic balance back. And it really works. People have found it to be have a huge advantage in athletes who make sure they have a good electrolyte balance when they drink this after a workout.